I want to look at the second half of test review for the second test, okay? So we already looked at questions 1 through 15. There's about 30 questions on the second test. So let's take a look at question 16. This one says simplify. It is a square root. It doesn't say, it doesn't have a 2 or a 3 or a 4 for the index, but that means we can assume it's a square root. From there, what we're going to want to do is think about each part separately. So I'm going to start with the numbers, the square root of 98. Now, if I think about the square root of 98, I'm going to try to factor that. And I can factor that as 49 and 2. 49 times 2 is 98. But my radicals, my square root rules say I can multiply two square roots just like this. I can pull them apart. I do know what the square root of 49 is. It's just 7. The square root of 2, I don't know what that is. It's just square root of 2. It doesn't actually simplify. Let's deal with the square root of a squared. The square root of a squared, since this is the square root and this is squared, that is just going to be a. In other words, the square root cancels out the square. When I look at the square root of b cubed, it's not just going to cancel out because they're not the same number. However, what I can do is I can say, can I split this into something that is squared? Just like we did with 98. And the answer is yeah, I can split it into b squared times b. From there, I can square root the first one and square root the second one. The square root of b squared is just b, and the square root of b is square root of b. Now I'm going to put all these three back together. I'm going to put the outsides on the outside, so I'm going to have 7ab, and then on the inside I have square root of 2b. The order is not super important, but let's make it alphabetical. Writing this expression in radical form, it's written with an exponent, and the exponent is a fraction. So there's actually a couple different ways we could write it in radical form. The first way is to say 9 cubed, and then the 1/5 means we're taking the 5th root. I could write it that way. The other way I could do that is I could write it as the 5th root of 9 to the 3rd power. Okay, so either one of those would work. Simplify the expression. This is asking us to do the 4th root of 16. The 4th root of 16 means that I'm taking the 4th root of 16 like this. So I need to come up with what do I have 4 of if I were to factor it. And when we break 16 down, 16 is actually going to be 2 times 2 times 2 times 2, or 16 is really 2 to the 4th. Which means 16 to the 1/4 is just 2. Simplify this expression. Now, I get a little bit scared because we have negatives, but we're not going to freak out about the fact that there's negatives. We're going to see what happens. I want you to notice that we do have an answer choice that says, hey, it's not a real number, which may come into play. So let's find out what happens when we have negatives. The scary part is trying to decide where the negatives apply. And so what I'm going to do here is I'm going to notice that there's not parentheses around -8. Which means I do not apply the exponent to that negative. Big mistake people make is to think that -2 squared is 4. It's not, because -2 squared is 2 squared with a negative in front, okay? In that way, we need to then think about what these pieces mean. We just talked about in a previous problem that we can write 1/3 as a cube root, okay? So our exponent rules allow us to say there's going to be a negative in front of this whole thing. I can write this as the cube root of 8, and then whatever I get for that, I'm going to raise that to the -4th power. Taking that one more step is to say, well, the cube root of 8, that comes out nicely. That's just going to be 2. I'm going to leave that negative in front, outside the parentheses, and I need to raise that to the -4th. Now, if we remember for a moment what negative exponents mean, that actually means we're going to write this as negative. Negative exponents means we put them on the bottom of a fraction. So now that we have it like this, I'm going to go ahead and say 2 to the 4th, which we saw in a different problem, is going to be 16. And so my solution is going to be that negative 1 over 16. The negatives looked scary. We had to deal with the one in the exponent, and the one that was in front, because it wasn't in the parentheses, we didn't have to apply the exponent to it. We just left it in front of the whole thing. I actually ended up putting it on top because I like that a little bit neater. Number 20, it says simplify. Now, these two cannot be subtracted. They cannot be subtracted because they are not like terms. If only we could make them simpler so that they were both, say, square root of 3. So the question becomes, can we simplify either one? Square root of 3 cannot be simplified, but square root of 75, we're going to say, can we factor that? And I can think of 25 times 3. Remember that square roots we can split up as long as we keep them square roots. The square root of 25 is 5, and the square root of 3 is square root of 3. Now the mistake I see people make on this problem is they go, okay, 5 square root of 3 minus square root of 3. But this started with a 5 out front in the beginning, which means it still has a 5 out front. And when we go ahead and take that, we need to multiply it 5 times the square root of 5, or 5 times 5. So this ends up being 25 cube root of 3. Don't forget those coefficients that are in front of the radical before we start. Now when we subtract cube root of 3, we end up with 24 cube root of 3 because we're just taking 1 cube root of 3 away. Looking at this one, we want to multiply, which means we want to go ahead and distribute. And then after we distribute, we want to simplify. So when we do that, the first thing we're going to get is we're going to get 7 square root of 175 plus 2 square root of 50. From here we say, can we simplify this at all? And I'm going to say this one can definitely, we can go square root of 25 times 2. This one is a little bit less obvious, but I think I can take a square root of 25 out of this one as well. 25 times 7 is going to give me that 175. Okay? Now, remember that when we have a number on the outside already, we need to multiply it with the new number we're putting on the outside. So we end up with 5 times 7 is 35. The square root of 7 stays on the inside, plus 5 times 2 is 10, and we're left with that square root of 2. From here, we cannot add these together. We can't, because one's a square root of 7, one's a square root of 2. We can't make them the same, so we're going to leave it just like that. This one, when we multiply it out, we need to be careful because we're going to actually have to distribute twice or FOIL it out. So the first one I'm going to do is I'm going to do 2 times 5. That's 10. 2 times the square root of 2 is going to be 2 square root of 2. 5 square root of 2 times 5 is going to be 25 square root of 2. And lastly, we have 5 square root of 4. In order to simplify all this out, what we're going to see is we have these two combine to just 27 square root 2. And then this one can actually be simplified because the square root of 4, that's really a 2. So 5 times 2 is 10. I have actually a 10 in the front and a 10 in the back. So what we're going to do is we're going to go ahead and combine those to be 20 plus the 27 square root of 2. Simplify by rationalizing the denominator. The denominator is not allowed to have a square root in it. And so what we're going to do is we're going to multiply by 7x to the 5th, the square root of 7x to the 5th on the top and bottom. The reason we do that is because we are not allowed to have the square root on the bottom, but if we multiply two things that are the exact same in a square root, it cancels out the radical. And so this ends up being 7x to the 5th without a radical because we had two pieces that we multiplied together, which blew it up. On the top, though, we do end up with x and square root of 7x to the 5th. From here, we're going to want to start simplifying. Before we cancel stuff out, I'm going to try to simplify the 7x to the 5th. The square root of 7 is going to be ugly, but square root of x to the fifth, how many sets of 2 can I come out with? That's the square root of x times x times x times x times x. That's 5. So I can get a pair here and a pair here. So square root of x to the fifth is really x squared, 2 sets of 2, times the square root of just 1x left over. Which means if I were to put that with the x I already have, on the top I end up with x cubed, square root of 7x, remember that 7 is stuck in there, over 7x to the fifth. This is not all the way simplified. It's always a bummer when we do such great work and then we end up with the wrong answer because there was one more step. And that's because there's something I can take out of the top and bottom. It's not the 7, because one of those 7s is in a square root. It's actually the x to the third and the x to the fifth can simplify. I can take out 3 x's there, and it ends up being square root of 7x over 7x squared. This one, we actually have a radical over a whole fraction, which is the same as having a fraction of 2 radicals. We can split that up. And so in the same way, we need to rationalize this. The denominator says you cannot have a fraction in a square root, cube root, or anything like. So what we're going to do is we're going to say, first, let's split this into the cube root of 1 and the cube root of 7x. When we do that, the cube root of 1 is just 1, so that's kind of nice. But on the bottom, we still have the cube root of 7x. The problem I have here is I need to get rid of that cube root on the bottom. It can be on the top, but it can't be on the bottom. And so what do I multiply that by? Now, if we did it like it was a square root, we'd just say, oh, multiply by the cube root of 7x on the top and bottom. The problem with that is that if we multiply those together, we don't end up canceling out the radical because the cube root is supposed to have sets of 3. So what we're going to do is we're actually going to multiply it by the cube root of 7x twice. That way we have a set of 3 on the bottom. This set of 3 on the bottom becomes just that 7x. It cancels out the cube root. On the top, we're going to put these pieces together. We're going to multiply the insides of the radical together, and we end up with the cube root of 49x squared, and we're going to leave it just like that. Solving radical equations is actually easier than simplifying. First thing we're going to do when we solve this is we're going to get the radical by itself by subtracting 1 from both sides, and we get the square root of x equals -3. Then we're going to square both sides, and we get x equals 9. Okay, great, so we got the answer. But I want you to notice when we're doing radical equations, one of the options is there is no solution. If we take that x equals 9 and plug it back in, we get the square root of 9 is 3, plus 1 is 4. But it wasn't supposed to be 4. It was supposed to be -2. So this actually is a no solution. It's what we call an extraneous solution, because even though we got it by getting the radical by itself, squaring both sides, we ended up with something that is impossible. It didn't actually solve the equation. Cube roots have less chance to be no solution because cube roots are allowed to be negative. This one's already by itself, so what I'm going to do is I'm going to cube both sides. And when I do that, I get 3x plus 7, because that blows up the radical, equals 3 cubed. Now 3 cubed is not 9, it's 27. Now, from here, I'm just going to solve that by subtracting 7 from both sides. And that gives me 20 equals 3x. And I divide by 3, and I get x equals 20 divided by 3. Which looks really scary, and you go, oh no, I got a fraction. I think it must be wrong. And so before you erase it, take this, and if you plug it back into that formula, what you're going to notice is, guess what? That is actually the right answer. It worked. We look at number 27. It's another radical. This one's a square root, so we're going to square both sides. When we do that, it blows up the radical on the left, but it gives us an x squared on the right. To solve a quadratic, meaning we have an x squared in it, what we're going to do is we're going to get it equal to 0 by subtracting everything over there. So I'm going to say x squared minus 10x plus 9 equals 0. I'm going to solve this by factoring because I can see what jumps out at me is this is going to be an x minus 9 and an x minus 1, okay? So I'm kind of blown by that because we talked about factoring in our last class. And that means our answers are not negative 9 and 1, it's actually positive 9 and positive 1. So now all that's left is to take those two and plug them back in to see if it works, okay? If we plug in the 9, we get 90 minus 9, and that's 81, and we square root it. But if we plug in the 1, does it still work? And the answer actually is yes. So both of these are correct solutions. Number 28, simplify using I notation as needed. This is a square root problem, and we can deal with the negative in a minute, but first I just want to simplify the square root of 180, okay? I'm going to try to factor this, and so I'm going to say, well, that's 2 goes into 90. 90 is like 9 and 10 is 5 and 2, and 9 is 3 and 3, and do a big factor tree. That's not normally the way I like to do it, but I wanted to do it once. And I wanted you to notice we have a pair of 3's, and we have, I'm going to try to loop these together, a pair of 2's. What's left over is this 5. So if we were to just simplify square root of 180, we'd just say 2 times 3 times the square root of 5, or 6 square root 5. If it was just square root of 180, but it's not. It's the square root of negative 180. And so that's like the square root of negative 1 times the square root of 180. We already know that what the square root of 180 is. It's 6 square root of 5. What's the square root of negative 1? Square root of negative 1 is just I. Just the letter I, lowercase I. So that means our answer to this problem is going to be 6I square root 5. Number 29, we have a square root. This one isn't too bad because we can square root the top. And again, I'm ignoring the negative for a second and square root the bottom. And then we also have to square root negative 1. If I do all those pieces, what I'm going to end up with is I 2 over 3. Or you might rather have this as 2/3 I. This one asks us to add or subtract, and this looks really scary, but trust me, it's not. When we add or subtract two complex numbers, there's some imaginary parts. That's what the I means. And we treat it just like variables. We add the real parts with the real parts and the imaginary parts with the imaginary parts, which means what we really are going to do to solve this problem is say 4 plus 6/5. In order to do this, we probably want to get common denominators. So I'm going to multiply both the top and bottom here by 5. And so that's 20 over 5 plus 6 over 5 equals 26 over 5. So my real part is going to be 26 over 5. My imaginary part is just going to be 3i minus 6i, and so that's minus 3i. When we multiply, it's a little bit more complicated because the thing that we need to do is we need to double distribute. We need to FOIL. So we're going to have, I'm going to move this just so that we can make sure we see it all. We have 5i times 3i. That's going to be 15i squared. We have 5i times 8, so that's plus 40i. We have negative 4 times 3i, so that's negative 12i. And negative 4 times 8, so that's negative 32. I want you to notice we can combine these two, but I also want you to notice that I squared right there, I squared is negative 1. And so that's going to give me negative 15. And I can combine that with the negative 32. And when I combine that, what I'm going to end up with is negative 47. The i's combine to be positive 28i. Now, if you wrote it like this, you'd unfortunately get the answer wrong because it's going to be actually in a plus bi form, which means the I needs to be at the end. So we're just going to write negative 47 plus 28i. Last question here is we're going to divide, and this is really about multiplying by the conjunction, or the conjugate, sorry. I'm doing multiple things here. Conjunction would be in conjunction junction if you know Schoolhouse Rock. And that means we're going to start by multiplying 9 minus 7i on the top and bottom. And we're going to have to distribute that out. What we're going to end up with is a real number on the bottom, but we're going to have to combine and simplify it, and we'll have a complex number on the top. That's about it for me. Good luck.